Okay, putting it together now. Taking some triangles and then determining if they are congruent by side, 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 or side, angle, side, or neither of those two. Totally possible. They may be lying to you. And then we're going to ignore the second part that says write a congruency statement. We did that enough. That was the 1, 2, 3, 1, 2, 3 thing. We're going to just not do that. We're only going to focus on how we can prove these things are congruent. Number one, I want to zoom in on this. Should have done that before. You know what? A good teacher would have done that. Too bad you have me. That is unfortunate for everyone. Zoom. There we go. Okay. Looking at number one. I see a side. I don't see a third side. So it's not side, side, side. I might be congruent, but I don't have enough information on the picture, so I can't make that statement. But what I do have are two sides leading to an angle. So I have that nice sandwich of side, angle, side. I got a side, side, and in between, I got an angle. So this over here, side, side, angle. That one's full of sass. Number two, here I have one side, two side, two side, but where's three side? Side three is in the middle. Because remember, if we could pull those apart, that side would go with both of them. Here I have side, side, side. Number four, here I have side, side, no third side, no third side. But where those sides meet up, is there an angle in between them that I can sandwich and prove? No, the angle is over here. That's not in the middle where I need it. That's not good enough, okay? Don't fall for their lies. Not congruent. Three. Oh my goodness, lots of stuff is happening here. Okay. All right, well, this picture is kind of gross. So that's just, I got two triangles here. I got two triangles. This one here on the left. Okay, that is one triangle. It just happens to overlap with another triangle. Yeah, I guess I'll use, I don't know. Whatever, we're doing that one. It overlaps with this triangle here. Okay, so I have the same triangle, kind of, maybe, copied over top of itself and flipped. Now let's look for the matching parts. Here I have a side. I don't have enough information for the other side. I don't know that this one matches this one. But do you see where the yellow and the blue overlap at the bottom? Okay. That's gonna be important because they share that side. If I were to drag these apart, that bottom would go with both of them. So here I have side, side. I don't know anything about this side. So it's not side, side, side. There is an angle in between them. Where side one and side two meet up, I have this angle here. And over here, where side one and side two meet up, I have that matching angle there. So this might be one of the more confusing looking ones, but that is sass. Number five, I have one side, two side, and if they share a side, we count it. So side, side, side. 6, I see this little parallel line indicator. That tiny little arrow tells you that this line is parallel to that line. So angle relationships are on the table, and that's probably important. So here, all right, I have a side, another side. I don't know anything about this side though, so it's not side, side, side. If it were to be SAS, there's only one place that angle could be where it would work, and it's between line 1 and 2. It would have to be here. It would have to be. Down in this triangle, it would be between 1 and 2. Where they meet up, it would have to be there if it were SAS. So that's C. Knowing that these are parallel lines, and this is the transversal connecting the two lines to each other, it looks like those angles are both on the inside. and one is on the bottom, the other is on the top, so that is going to be alternate interior. And I know alternate interior angles are in fact congruent to each other. So I do have side, angle, side, side, angle, side. Honestly, that one might be easier than this double overlap one up here. Maybe this one's easier to see. Number 8. I got a side, I got a side, 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 no third side. Can't say side, 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 can't do that. But if it were to be SAS, the angle between number 1 and number 2 would have to be there. And down here, between 1 and number 2, it would have to be there. Is there a way I can say that those two angles are equal to each other? And the answer is yes, because those things are vertical. And vertical angles are congruent. Do you have it tattooed on your body yet? It's important that you know that, okay? Vertical angles are congruent. I've been saying it a lot. Seriously, get it tattooed. Go to a shop, spend a couple $100, get vertical angles are congruent tattooed on you. You will be the coolest person in your college. All right, so this is gonna be side, angle, side. 7, our last one. Okay, I see a side, 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 side. I see an angle. I got all the makings for SAS, but I got a problem because where the two sides meet up, that's where the angle would have to be. That angle is not there. So this is not congruent. Okay, complete each proof using the most appropriate method. So now we're mixing it up. It might not be obvious. It might not be immediately side, 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 or side, angle, side. We have to figure it out. But we do have some given pieces of information, so let's take our free points. And I'm trying to prove that ABD is congruent to triangle CDE. Okie dokie. Hey, look at that. Over half of the problem was free points. When people say proofs are hard, okay, they are, but I mean, half the points were free here. Okay, let's not give up on our old habits. Let's go label our picture. Told me AB matched CD. It said AB was parallel. Okay, that parallel thing probably means angle relationships. AB is this one parallel to that one. I didn't cover that super well, but oh well. And then D is the midpoint. Oh, love seeing midpoint. Love seeing that. D is the midpoint. So a BE, excellent. This matches that. Love to see it. Okay, so here's my statement that I'm gonna see. D is the midpoint. I'm gonna use definition of midpoint, right? I think a lot of you probably get to the point where you're like, okay, midpoint, definition of midpoint, wonderful. But then you're like, what do I put in this box? What do I say because of that? What's my statement? Well, it's the same thing that I drew up here, right? D is in the middle of BE, so that means this piece, this half, is congruent to that half. I'm gonna say that BD is congruent to DE. Okay, so now I have my midpoint taken care of. I've labeled my one side. It gave me this piece of parallel information. That's what I'm probably gonna need to use to figure out my last box here. And the parallel only unlocks angles for me. Doesn't talk anything about sides. I'm looking for angle relationships. So, let's see. If I look at these two lines, this line and this line, what's the transversal? What's the line connecting those two? This one right here. This line starting at that purple and ends at this purple. So I need to find two angles that potentially match each other. I see that, let's see, this one. Well, I want to get inside the triangle, right? Don't I? Don't I want to get inside the triangle? So that means I would need to find something similar. Like, what I'm thinking is, I want to talk about inside this angle here. I want to do this. I want to. But the matching angle there, alternate interior, would be there. Inside the lines on opposite sides. That's alternate interior. That's usually what we use. But this one's on the inside. That one's not on the inside of this triangle. So that doesn't do anything. I need it to be on the inside for it to work. Huh. Okay, so maybe that's a trap. Okay. On this, there's another angle here. Other than that one, there's this angle here. And that one there. Those match. Okay, those are going to be congruent. What's the relationship though? It looks like they're in the same spot. When they're in the same spot, they're corresponding. They're corresponding angles. Okay, so here I will say that angle. I have to describe that first one. ABD is congruent to the other angle. If I want ABD, I need to go CDE. Okay. All right. Now, I have two sides that are congruent. I don't know about the third side. And in the middle of these two sides where tick 1 and tick 2 meet up, there's the angle. I have that SAS sandwich. And maybe that would have been a smarter way to do the problem in the first place. Like, we knew going in that it was either going to be side, 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 or side, angle, side. We knew that because that's the topic. But why did I maybe try to force this angle up here? If it was side, angle, side, the only place that angle could have existed was between the two lines. So I could have started there in the first place, and maybe some of you did, and you got the answer faster than I did. Okay, let's label our picture and like fill in our stuff. Okay, M is congruent to NM. That one was given. And LK is congruent to LN. That one was also given. The thing I'm trying to prove goes in the bottom. Triangle LKM is congruent to triangle LNM. Okay. I labeled all my things. I got all my free points. I'm gonna go draw on my picture now. KM, boom, matches NM. LK matches the other one. I see that overlapping side. That's gonna be important for me. I'm gonna use that. So my statement is gonna be that LM is congruent to itself, LM, and the reason is reflexive. Now I have three sides that match each other. There we go. Okay, got some given. Why did I write that there? Oh man, all right. That's where given goes, but what was given? AD is congruent to AB, bam. AC bisects, angle, dab. That one's given. All right, I see the word bisect. I'm probably going to use definition of bisect at some point. That seems like a thing that's smart. But I'm trying to prove that triangle ADC is congruent to triangle ABC. All right, how are we going to get there? AD. Hey, AB, they already drew on my picture for me. That's upsetting. AC bisects DAB. Okay, so we're talking about an angle. AC is cutting something in half. This line is cutting one angle in half. DAB, it's cutting this one. So that piece is gonna match that piece. All right, right here, I know that they match each other. So here's my angle statement. It's going to be that that bottom one, the angle that's facing downward right now, DAC, angle DAC is congruent to the other angle, the one that's going that way, BAC. And my reason is definition of bisect. Because remember, bisect means to cut in half. Okay. Now I don't know anything about the side other than this one side it gave me. I can't prove anything else. But what I do know is that two triangles here share a side. So one of my statements is going to be that AC is congruent to itself, AC, and that's going to be the reflexive property. So now I have two sides, side 1, side 2, with an angle in the middle, SAS. All right, we got some stuff I'm not going to write given here. I'm not going to do that this time. It's congruent to an M given. L is midpoint of JN given. And I see the word midpoint. I'm just going to write definition of midpoint. I'm just going to do that. I know I'm going to use that at some point. Okay, the thing I'm trying to prove. JLM congruent to angle NLM. Terrible N. Yes. Okay, label the picture. JM, that one. Congruent to NM, that one. L is midpoint. L is midpoint of what though? JN. So that means this half matches that half. That's my statement. That JL is congruent to LN, and the reason is definition of midpoint. Okay, right here, I see a side that the triangles share. I see that, so LM congruent to LM, and if something is congruent to itself, it's reflexive. And now it looks like I have side, 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 three sides, no angles. Boom. Last page, okay. All right. I'm given a triangle. Given these coordinates, determine whether these triangles are congruent to each other. So basically, we have three coordinates. We have, I don't know, I'm gonna do a rough sketch here. Here's a coordinate grid. Point P is 5, -4. Over 5, down 4. That's P. Q3 is -3, up 7. Q. And then R is 0 left and right, and 2 up. Wow. Okay. Well, this is a looks like a straight line, but apparently if I were to draw it to scale, it's supposed to be a very skinny triangle. That's a terrible triangle. It's terrible. But we're trying to see if that one is congruent to this other one. Man, that is a bad triangle. Terrible example. Again, I'm gonna leave it in the video. You can laugh all you want. But that's what we're trying to do. So we're going to use the distance formula here 3 times for each one. And then we're going to see if we get matching sides. Let's see though. It's 1, 2, 3, 1, 2, 3. And I hope these match up. So PQ is 1, 2. XY is 1, 2. Okay, QR 2, 3, 2, 3. Okay, so yeah, everything's going to match. If this number matches this number, we're good. We're going to keep going. If this number matches this number, we're good. But suddenly if I get down here and the number, like this one doesn't match that one, I'm gonna stop because they're already not congruent. We're just trying to figure out if side, side, side. We can't use angles in the coordinate grid. We're not that good yet. But right now we're gonna use sides only. All right, distance formula time. Come on. Come on. Zoom in. There we go. So the distance formula, distance equals square root x2 minus x1 squared plus y2 minus y1 squared. it tells me PQ is the one I'm gonna be doing in this box. So for this problem, I'm going to label this x1, y1, x2, y2. As I go forward and do the other ones, I'm gonna remove that label. But for now, this is what I'm gonna do. Distance equals big ol' square root. The formula says x2. x2 was -3. The formula says I subtract x1 from that. 5. Close it, square it, add y2, 7, minus y1, -4. Close it, square it. Distance equals, all right, -3 minus 5 more gives me -8. Minus a negative turns positive, so this is 7 plus 4, which is 11. Anytime you square anything, it turns positive, anytime. So this is going to equal the square root of 8 times 8, which is 64, plus 11 times 11, which is 121, which is going to equal 185. Keep it in a box, that's the answer. Now let's go over to the other side and see if we get that exact matching number. Distance equals square root x2 minus x1 squared plus y2 minus y1 squared. Okay. x1, y1, x2, y2. Let's see if we get the same thing. Distance equals big ol' square root x2, which was 9, minus x1, which was -2. Close it, square it, add y2, 7, minus y1, -1. Close it, square it. Okay. Distance equals, subtract the negative turns positive, 9 plus 2, 11, plus, subtract the negative, add it, 7 plus 1, 8. All right, I'm starting to see that those are the same numbers that we had over here, which is gonna mean this is a square root of 121 plus 64 equals square root of 185. Okay, so I did get the same number. I did. I have to keep going. Okay, that would have been really good if those didn't match, because I would have known that they didn't overall, but too bad, we go on. Distance equals big ol' square root x2 minus x1 squared plus y2 minus y1 squared. All right, now I have to change my labels, man. I have to change how I label this. What's what now? QR? So we're talking about these two. x1, y1, x2, y2. I'll go over here and do the same thing. x1, y1, x2, y2. Okay. I can use those numbers now, which is going to be annoying because I don't have them on the screen. I'll have to do that. Okay. Distance equals big ol' square root x2, which in this time is 0, minus x1, which is -3. Close it, square it, add y2, which is 2, minus y1, which is 7. Close it, square it. All right. Distance equals big ol' square root. Subtract negative turns positive. 0 plus 3 is 3. Plus 2 take away 7, that's going to be negative, right? Negative 5. Square it equals square root. Anytime you square something, it turns positive, so 3 times 3 is 9. Negative 5 times negative 5 is positive 25. All right, so 34. 34 is the number we're looking for. Let's go over here and do that. Distance equals big old square root x2 minus x1 squared plus y2 minus y1 squared. Let's not cut that off. Okay. X2 in this problem is a 3. 3 minus x1, 9. Close it, square it, add. Y2 in this problem is 2. Minus y1, which is 7. Close it, square it. Okay. Distance equals big ol' square root. 3 take away 9, negative 6 squared plus that is negative 5 squared. All right, that's gonna be 6 times 6 is 36. We know 5 times 5 is 25. Hey, wait a minute. That's gonna be, what, 61? No. Well, 61 isn't 34. 61 doesn't match 34. I don't have to keep doing this. Unless I messed up, I'm gonna check at the answers. No. Wait. Wait a minute. Brain power activate. I don't know if that's right. But we're gonna keep going because it says that it is. I was really hoping because these should match, right? Congruency statement. I don't like it. Anyway, we're gonna keep going because it says that it is congruent, spoiler alert. All right, so basically what happens is, I'm gonna jump ahead for you because you can do the formula on your own if you really choose to. This one down here becomes the square root of 61, and this one over here becomes the square root of 34. And now it says that because, all right, you have 3 matching sides, a 185 matches here, a 34 matches across there, and 61 matches across there. I guess our congruency statement doesn't really matter. Today I learned, all right? Maybe because it's been a couple years since I've done this, but I guess I forgot that little thing. You have 3 matching numbers, you have 3 matching numbers. The answer is yes, these are congruent. So, are the triangles congruent? Yeah. 3 sides match. Okay, we don't need to go any further than that. Okay, I'm not gonna, for the purposes of this video, because you saw a distance formula enough, you can go through and you can do it on your own. You can try this one, okay? You can go ahead and try that yourself. Spoiler alert, I think the answer might be a little bit different than the other one. Okay.